Mrs. Lopez went for a 3-hour walk. First, she walked on a flat road, then uphill, and finally she walked back to her starting point along the same route. On the flat road, Mrs. Lopez walked 4 kilometers per hour. Uphill, she walked 3 kilometers per hour, and downhill, she walked 6 kilometers per hour. Find the total distance that she walked. Alright, this problem just almost looks like it doesn't have quite enough information, but let's work with what we've got. First, I'd like to draw a picture. So she walks along some flat portion of her route, and she walks along the flat route at 4 kilometers per hour. Okay? And we don't know the distance, so that's what we want to end up finding is the total distance. So we'll just call this for right now, we'll just call it x. Okay, so she walks some distance x at 4 kilometers per hour. And then she walks uphill. Alright, so here's our uphill portion. And uphill she walks at 3 kilometers per hour. Okay, then she gets to the top of the hill, I guess, and then she turns around and comes back down the hill, and she walks at 6 kilometers per hour down the hill. Alright, and she finally returns to this flat portion and walks 4 kilometers per hour again, and then she gets back to her starting point. And so this uphill portion, I don't know the distance there either, but I'm just going to call it y. Alright, so I'll just stick it in here. Y. Y will be the distance that she goes uphill. Alright. And the other information that we're given is that it's a 3-hour walk. So we know her total time. We know that she walks for 3 hours. Okay? So, and we also know that distance is equal to rate times time. Okay? And so for each portion of her walk, she goes up, in the flat, then uphill, then downhill. Each portion of that walk, she's walking at a constant rate. Okay? So when she's walking on the flat portion, she's walking at a constant 4 kilometers per hour. And we can rearrange this equation to get time. And so time is equal to distance over rate. Okay? So what I'm going to do is I'm going to add up all the times it takes for her to walk each portion of her route, and then that total should be equal to 3 hours. So on the flat portion she walks x kilometers, and she walks it at 4 kilometers per hour. Okay? So that will give us the time it takes for her to walk that first portion on the flat road. Then she goes uphill. She goes for a distance of y, and she walks at 3 kilometers per hour. Alright? Then she turns around and goes downhill. She again walks a distance y at 6 kilometers per hour. And then finally, she's back on the flat road. She goes the distance of x at 4 kilometers per hour. Alright, now that should give us the times for each portion of her route, and if we add them all up, we should get 3 hours. Okay? Because that's the total time that we're told that she walks. Alright, so let's try and simplify this. Alright, well, I've got x over 4 plus x over 4. Alright, that gives me 2x over 4, or I could write it as x over 2. And then I can add these y's. Now I have y over 3 plus y over 6. So I could write this as 2y over 6 plus 1y over 6. So that's 3y over 6. Okay, so 3y over 6 is just y over 2, right? Because 3 over 6 is just a half. Alright, and then finally that's equal to 3. Hey, now we're getting to something more manageable. Let's multiply through by 2. So we get x plus y is equal to 6. So what does that tell us? That tells us that the distance for a one-way trip, where she gets to the top of the hill, she walks x plus y, which is 6, and our units here are kilometers, because that's what our miles, our rate, that's what our rate is in kilometers per hour, and our time is in hours. So this gives us 6 kilometers. But that's not her whole route. That's not the total distance. That's just one flat portion plus one uphill. But she's got to come downhill and then on the flat portion again. So she's going to end up walking 2x plus y. All right, so that'll be equal to 12 kilometers. And that's what we need to find is her total distance. So her total distance is 12 kilometers.